Okay, algebra students, we are back. Now, as we're doing this, we're realizing something very, very, very interesting here is that we have these questions that is very, to me, some people might be very difficult to picture in their mind. And I have this a lot when I do physics work, where we're talking about a whole bunch of things, and I really don't understand what this looks like. Maybe I have a hard time picturing this in my head. Okay, so I have a little guideline here of how to solve these things. I'm going to get a little pen out and do this with a pen. Underline all important pieces of information. Well, I'm looking at all the numbers. 6 feet tall. 3.5 feet in the shadow of the... What is the height of the flagpole? Well, I have a height here with the man, too. We're going to keep that in mind. I have a height of a flagpole. Shadow. A shadow is 3.5, and a shadow is 17.5. So if you see, I have two heights. I'm going to label the other height. Well, this one is an unknown, because they want to know what it is. But this is a shadow. And this is a shadow. So what are we trying to solve for? We're doing the height of the flagpole. And that is going to be, I guess we'll call it x in this case, right? Write an equation to solve this. Okay, so now, here's where I see it. Okay, so I'm going to get out some green for grass. Imagine this person, right, is a man, okay? So there's this guy, and he's out on in a park or something like that. And our man, he decides he's kind of standing here. And then there's a giant flagpole. Let's see if I can draw a good flagpole. I'm not the best flagpole drawer. Can't do it enough to put stars in there, but maybe some stripes. We'll keep it an American flag for now. That's not a bad American flag. If you squint, it looks like an American flag. So there's this flag blowing, and then you have this guy over here. Now, his height, which is his, from his, as we know, is from the ground up into the top of his head. And this height, I'm going to highlight it in red so we can see this. His height is 6 feet tall. Now the flagpole's height is the one we're solving for. That is going to be an x. I just don't know. Now the next thing that I like about this problem, because it's interesting, is that we have to talk about the shadow. And what does the shadow look like? Well, let's imagine the sun is going in one direction or another. I'm going to put my sun over here. It doesn't really matter. But if you think about it, if you think about the sun for a second and your shadow, all the shadows are always in the same direction. So if the light is shining this way, all the shadows are going to be on this side of the objects. Now, if it was over here, our sun was over here, the shadows would be on this side of the objects. And if the sun was directly above, there actually would be no shadows. Okay? So, in my case, the sun is shining here, the light rays are coming in like this. And now what happens is these light rays come in, let me use a little bit of yellow to illustrate this. They're all coming from the same point. So I get this kind of a light ray that kind of goes here, right? It misses the top of the man's head, it lives on the floor. Same thing over here. Now, since the sun is the same angle to both of these, because it's so high up in the sky, I'm starting to realize something here. I got this yellow. I have this yellow. You guys starting to see a shape. What we have here is what we call a right triangle. Okay? Now, they're saying, well, Are these two right triangles similar? Well, yeah, because when you stand up, you make a 90-degree angle with the ground, and this flagpole makes a 90-degree angle here. We always have things we call perpendicular, right? When things are standing, they're usually perpendicular. Very rarely are they not perpendicular. Usually they fall over. So you gotta have a flagpole that's straight up and down into the ground, and you gotta stand kind of straight up and down, otherwise you fall over, right? So you got these right angles here. So this is 90 degrees. This is 90. And then the angle from the sun to the shadow is the same in both of these. I don't know what they are. And that means actually that the next one has to be the same. So I have two similar triangles. Now, next part is I got to draw my shadow. Well, shadow is just like a dark mark on the ground. Dark mark on the ground. You see my right triangles now? Now we have the right triangles. From here to here to here to here. From here to here to here to here. This is my shadow on the ground. And this is the flagpole shadow on the ground. Now, there's information for these two shadows. The man's shadow is 3.5 feet. And the flagpole's shadow is 17.5 feet. So that means, yes, again, we are going to use proportions. When you have similar figures, you can use proportions. Okay, so let's see, what do I want to put on top? Since they're on top, I'm gonna make this side the man, this side the flagpole. Because that's how they kind of line up in my picture. So on top here, the height of the man is 6. The height of my flagpole is, I don't know. So both of these top things are going to measure the height. So I keep the height being X because I just honestly don't know. Now my next thing is the shadow. Now since it's the man's side, the man's shadow is 3.5. And since this is the flagpole side, I keep the shadows on the bottom, the heights on the top, man on the left, flagpole on the right. Next step. Well, cross multiplication. Let's get another color. I'm going to go with blue now. 3.5 times x is this 3.5x equals 6 times 17.5. Again, it's a number. I'm going to let the calculator do because I can't do that in my head. 6 times 17.5 gives me 105. Okay, it's a nice round number. There we go. And my next step, well, got a little bit of a one-step algebraic equation here. 3.5 times x, remember, if there's nothing there, it means multiplication, equals 105. So if I want to get x by itself, I got to get rid of these numbers over here. And that number is 3.5. So I'm going to divide both sides. The opposite of multiplication is division. 3.5. Cross those out. X equals, next step, 105 divided by 3.5. Again, it's a number that I can't do in my head, so I'm going to use my calculator. No shame in that. 105 divided by 3.5 is just a nice even number, 30. So how tall is the flagpole? Well, since we defined it all the way up here, the height of the flagpole is x. X equals 30. And we're measuring everything in feet. So I don't have to have this x here anymore. This flagpole is 30 feet tall. So we call this indirect measure because we would never be able to do this realistically. If you had, you'd have to get a ladder. I mean, it'd be you couldn't like climb up the flagpole with a ruler and do it. If you had a ladder, you'd have to have something you could drop. 30 feet, I don't know anything that goes 30 feet as far as measurement goes, as far as if you could get a tape measure. Maybe it's a 30-foot tape measure. I don't know if I've ever heard of such a thing. But maybe, if you had a 30-foot tape measure, you could measure it out. But it's really impractical to climb up here and measure. It's the hardest way to do it. The easiest way to do it is use what we have here, which is proportions. So the important rule with proportions is that we match things up. If I'm going to make the man on this side, or the left triangle on this side, and the right triangle on this side, I want to keep the red components in both of these. The red sides on top. The black sides I put on the bottom. Man information goes here. Flagpole information goes here. Do my algebra, cross multiplication, and I'm done. So I want you guys to have a great day. Okay? And I will talk to you soon. Good job.